gentlemen, we will start this webinar today. So before we are going to start this session of the agenda, I will need a little bit of your assistance. Make sure you have a stable internet connection and have a comfortable place to follow this session today. So we'll focus and we will have a maximum result. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
The Honorable Dean of Faculty of Industrial Technology, Universitas Islam Sultan Agung, the respectable Deputy Dean for Academic and Partnership Affairs, Deputy Dean for Administrative and Finance Affairs, and the respectable Head of Industrial Engineering Department, Faculty of Industrial Technology, and also the respectable speaker of the Industrial Engineering webinar series today. The first is Dr. Muhammad Farid bin Sari and Associate Professor Dr. Muhammad Mozaser Rahman from University Tun Hussein on Malaysia. My beloved students, ladies and gentlemen, very good morning and warm welcome to the Industrial Engineering webinar today. It's my pleasure to be your Master of Ceremony, and my name is Indah Setiawati. On behalf of the committee, we would like to express our warmest welcome and greatest appreciation for attending the seminar today. So, ladies and gentlemen, first of all, let us extend our sincere gratitude to Allah Subhanahu wa Ta'ala, the Lord of the world, who has given us his blessing and mercy so that we can hear in this webinar today. Praise and salutation upon our Prophet Muhammad Sallallahu Alaihi Wasallam, the last messenger, the best figure of the universe, who has guided us from the darkness to the lightness. So, ladies and gentlemen, along the days, this webinar series today will provide us plenty of opportunities to discuss and then share knowledge and insight, everything within our theme today, smart manufacturing. And here among us, there are Dr. Muhammad Farid bin Sari and Associate Professor Dr. Muhammad Mozaser Rahman for University Tun Hussein on Malaysia. And now we would like to proceed this conference by singing the national anthem of the Republic Indonesia, Indonesia Raya, and Hymne Unisula. So please stand up. Thank you, and kindly be seated. Ladies and gentlemen, now we would like to invite Ahmad Zainal Muntaha to deliver Al-Quran recitation. Please welcome.
Ya, ya sudah. Iya, ya tadi.
Ahmad Zainal Muntaha. Okay, ladies and gentlemen, for the next agenda, we would like to invite Ahmad Zainal Muntaha to deliver Al-Quran recitation. Please welcome Ahmad Zainal Muntaha.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
warahmatullahi wabarakatuh. A'udzu billahi minasy syaithanir rajim. بسم الله الرحمن الرحيم يا أيها الذين آمنوا إذا قيل لكم تفسحوا في المجالس إذا قيل لكم تفسحوا في المجالس فافسحوا يفسح الله لكم وإذا قيل انشزوا فانشزوا يرفع الله يرفع الله الذين آمنوا منكم والذين أوتوا العلم درجات والله بما تعملون خبير والله بما تعملون خبير صدق الله العظيم. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Ahmad Zainal Muntaha, and may Allah bless this fruitful webinar today. And ladies and gentlemen, now we would like to invite Head of Industrial Engineering Department, Faculty of Industrial Technology. Please welcome Ms. Nuzulia Khairia, STMT, to give welcoming speech.
Thanks to Mrs. Indah that gave me a chance to deliver my welcoming remarks to all webinar speaker and participant. Is my voice here, Miss?
Yes, Bulia, clear.
Okay, thank you. Bismillahirrahmanirrahim. The Honorable Dean of Industrial Technology Faculty, Sultan Agung Islamic University, Mrs. Dr. Novi Marliana, and along with the staff, the honorable speakers in this webinar, Dr. Muhammad Fari bin Syari and Associate Professor Dr. Mozazir Rahman from University of Tun Hussein on Malaysia, the honorable all of the lecturer, participant, and the student of Unisula who joined on this webinar and are blessed by Allah Subhanahu wa Ta'ala. Assalamualaikum warahmatullahi wabarakatuh. First of all, let me welcome all of you here in this special occasion. Nothing can be said except thanks to Allah Subhanahu wa Ta'ala for His blessing and mercies, so we can attend and gather in this virtual room without any obstacle and in healthy condition. Peace and greeting be upon to our Prophet Muhammad Sallallahu Alaihi Wasallam, who saved the human life from destruction in the safe and glorious era. That's the right path of Allah. Amin. Next, allow me to express my gratitude on behalf of the Industrial Engineering Department to the speaker of today, Dr. Muhammad Farid bin Shari, and Associate Professor Dr. Muzazzar Rahman from the University of Tun Hussein on Malaysia, who have agreed to attend and share knowledge with us related to the latest issue in the field of Industry 4.0. The Dean of the Faculty of Industrial Technology at Universitas Islam Sultan Agung, as well as the group in charge of organizing this webinar with the topic of smart manufacturing, and all the audience who attended on this webinar. This webinar is held as a form of cooperation between FTI Unisula and UHCM. The most relevant webinar theme that we organized for today's event is entitled Smart Manufacturing. As we know, in today's highly developed digital era, there is a new concept called intelligent manufacturing, and it is a part of the Industrial Revolution. Diligent manufacturing or smart manufacturing is also a new concept in the world of the manufacturing industry. As a part of the Industrial Board Partner, it is necessary for the Industrial Engineering Department of Unisula to conduct events beyond the lectures to provide scientific strengthening for students in relation to the latest scientific development. We hope that by bringing this theme up, students and all participants will get the latest information in the field of smart manufacture. I wish you a happy webinar. I hope it will be useful and all participants can be proactive here, I hope. Last but not least, we do apologize if there are some inconvenient things we have prepared for this webinar. Thank you very much for all attendance. And I say the last, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, Bulia, for your welcoming speech. Now, ladies and gentlemen, before we are going to the next session, I will remind to all participants to fill up the attendance form that will be provided in the chat box. So you have to double or 2 times to fill the attendance form. The first is for registration, and after that you fill for asking the certificate. And after that, we will take the photo session as a documentation for this activity. So I will ask to all participants to have your camera on. And I will ask, yes, from multimedia to take the photo. Baik, kepada seluruh peserta, khususnya kepada mahasiswa, untuk mengisi daftar hadir ya yang akan kami siapkan, berikan di kolom chat menjelang akhir acara. Pengisiannya dilakukan secara 2 kali. Yang pertama untuk registrasi, kemudian mengisi data, and then after that you will click for another tombol, ada tombol lagi untuk mengunduh sertifikat. Dan sebelumnya kita akan foto bersama. Untuk itu silahkan dinyalakan semua kameranya. Terima kasih. There are 165 participants in this webinar series. Okay, so we will take about 7 screens to document all participants. Okay, the first one, 1, 2, 3. Thank you. The next. Ya, multimedia, ready ya? Thank you. Next. Okay. Okay. Thank you very much. And then now we will continue for the next agenda in this webinar series. So ladies and gentlemen, now we would like to warmly invite our speakers today. The first is Dr. Muhammad Farid bin Shari. And then the second one is Associate Professor Dr. Muhammad Muzazzar Rahman. Both of them is from University Tun Hussein on Malaysia. and they will share their expertise to us. And this session will be chaired by our moderator, Mrs. Wiwi Fatmawati, ST Master of Engineering. Ms. Wiwi is a lecturer of Industrial Engineering Department from Faculty of Industrial Technology. Ms. Wiwi, the time is yours, please.
Okay, thank you, Mrs. Indah. Yeah. Before we start our talk today, let me check the sound first. Yeah. Can you hear my voice clearly?
Yes, it's very clear.
Yes, sure.
Okay, thank you very much. Yeah, Alhamdulillah. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And a very good morning.
Waalaikumsalam warahmatullahi wabarakatuh.
The Honorable Dean of Faculty of Industrial Technology, Universitas Islam Sultan Agung, Dr. Insinyur Novi Marliana MT, and the entire faculty members and staff, the Honorable Head of Industrial Engineering Department, Mrs. Nuzulia Khairiyah MT, all the lecturers, participants, and my beloved students who attend this webinar. And our special guest today, the Honorable speakers, Dr. Muhammad Farid bin Sari and Associate Professor Dr. Muhammad Mozassar Rahman, both from Faculty of Engineering Technology, University Tun Hussein On, Malaysia. Alhamdulillahirabbil alamin. All the praises should be to Allah Subhanahu wa Ta'ala, who has given us blessings and guidance so that we can gather in this webinar today. And our prayer and greetings should be delivered to our Prophet Muhammad Sallallahu Alaihi Wasallam, which we hope for his intercession in the Judgment Day. Yeah. Today we will have our second round webinar on online lectures exchange, and our special speakers are already with us in the Zoom meeting. Welcome, Dr. Muhammad Farid Sari and Associate Professor Dr. Muhammad Mozassar Rahman. How are you today?
Alhamdulillah, fine.
Okay, thank you very much for your time and for being with us today, Dr. Farid and Prof. Mozassar. Yeah.
Thank you.
Okay. Yeah. My name is Wiwi Fatmawati, and I will be in charge as the moderator of our discussion today. Yeah. The topic of our webinar is about smart manufacturing. Yeah, the interesting topic to discuss nowadays, especially when we go through the industrial revolution 4.0. Yeah, smart manufacturing is a broad concept, a combination of various technologies and solutions which collectively enables in optimizing the entire manufacturing process. Yeah. And now we have Dr. Farid and Associate Professor Dr. Mozassar, who will share their valuable knowledge and experience in smart manufacturing. But before we start, there are a few things to be noted. Yeah. Firstly, since we have two speakers in our webinar today, Dr. Farid and Associate Professor Dr. Mozassar Rahman, each speaker will have around 30 minutes to deliver their presentation consecutively. And secondly, the question to the speaker can be asked after the last presentation is finished. And thirdly, the question can be asked in person directly, or you can write your question in the chat box in this virtual room in English or in Bahasa Indonesia. So don't worry, if you want to ask in Bahasa Indonesia, it still be okay, yeah? And now I would like to welcome Dr. Muhammad Farid bin Sari as the first speaker in this webinar. But before he starts to deliver the presentation, let me read the short CV of Dr. Farid first. Okay. Professional technologist Dr. Muhammad Farid bin Sari is the senior lecturer in Department of Mechanical Engineering Technology, Faculty of Engineering Technology, University Tun Hussein On, Malaysia. He was born in 1979 and got his Bachelor of Engineering with honors from Manufacturing Engineering, University Kebangsaan Malaysia in 2001. Dr. Farid then continued his study in mechanical engineering and got his Master of Engineering degree from University Tun Hussein On, Malaysia in 2007. Dr. Farid got his PhD in robotics engineering from University Sains Malaysia in 2017. Dr. Farid Sa'ari research interests including machine design, biomimetic and bio-inspired robotic, industrial automation, smart manufacturing, and smart material actuators. Now allow me to welcome Dr. Muhammad Farid bin Sa'ari to deliver his presentation. Please welcome Dr. Farid. The time is yours.
Okay, Alhamdulillah. Thank you, Dr. Wiwik. Okay, our Honorable Dean, Dr. Prof. Novi, Head of Engineering Department, Dr. Nozulia, Chairperson, and my friend, Dr. Mozasir, and all to students and Unisula staff. So first of all, I would like to thank you given this opportunity to share my knowledge with you guys. And what I'm glad is it's not only for our knowledge sharing, but I also have given opportunity across country. So this is my first time giving lecture to Indonesian university in international webinar. So it's a good experience for me too. Okay, thank you. Okay, so now I would like to share my presentation. Okay, hold on. Okay, everybody can see this presentation, this slide.
Yes, Doctor. You can see
okay.
it.
Okay, Bismillahirrahmanirrahim. Okay, so today basically we have divided into two lectures, me and Associate Professor Dr. Mozasir. So the title given is smart manufacturing. So we split into two parts. So because I'm the first presenter, so I will give some brief introduction about smart manufacturing. So this is basically the content for my slide. So I will give definition. I will explain in terms of the definition and the concept of smart manufacturing, and then we have another definition or terms that always used together in manufacturing clusters, in manufacturing families. We have agile, responsive. We have another few more terminologies that always used worldwide about manufacturing. And then we can go to detail on conventional manufacturing and smart manufacturing. And then we go for smart manufacturing ecosystem, technologies, and characters. So we will go deeper about what is a smart manufacturing in general. And from smart manufacturing, basically we can divide it into smart factory, which is a smaller scale, is a part of the main element in smart manufacturing, as well as new technologies and smart products. And then before we close for my session, we will look a little bit into the challenges that are being faced by smart manufacturing globally, because as we know, in this world we have different level of country. There are some advanced technological countries, there are third world countries, so that's why the adaptation is different between the countries. And finally, I will go for a general conclusion. Then Dr. Mozasir will explain more about the IR 4.0, IoT, and so on. Okay, so generally this is how we divided this topic. Okay, so first of all, let me go to the definition first. So before we go in detail about smart manufacturing, so this is just like a revision. What is manufacturing? So I believe all of you, the students especially, you're from the industries, schools, right? Faculty. So I believe will be the general terminologies that everybody must know about what is basically the manufacturing. So according to dictionary, Cambridge Dictionary, so manufacturing basically is the business of producing goods in large numbers. So there are a few keywords here. The business, it is the business producing goods and large numbers. Large numbers means it will be produced in mass production. And producing goods means we are producing some things from raw material into finishing goods. And it is a business. This is a business. Why? Because basically if there is no manufacturing, no business. And if there is no business, no manufacturing. It's just like a two side of the coins, the different things, but it appears in one item. It's just two side of the coins. Okay, and there are another definition about manufacturing. This is quite general. I took it from Investopedia, and I believe there are many other references also have a general consensus about manufacturing definition, which is the basic one is processing of raw materials or parts into finished goods. Okay, so it is a process, or it is a conversion process from raw material parts to finished goods, and through the use of tools, humans, labor, machinery, and chemical processing. So this one I take from Investopedia definition. So basically the general definition, manufacturing, when somebody asks you, or your friends, your colleagues who are not from engineering background, so when they ask you what is a manufacturing, basically, so what we can say is, in a simple words, it is just a process converting raw materials into a finished goods. Okay, so this is in a definition in figures, in a diagrams, for graphical figures for easier to understand. Okay, so basically the manufacturing in the middle, in the center. So it converts raw materials. Let's say we have ingots here, and we produce a finished goods. And under manufacturing, inside the process, basically we have the manufacturing process. And of course, if there is a process, there must be a system. Okay, and it supports by labors, tools, and machineries according to what type of manufacturing strategies you want to use. Because we have automation, we have manual, and we have hybrid between manual and fully automated manufacturing, which is the semi-automated manufacturing. So I believe that one is basic. Why it happen like that? Okay, because it depends on the companies. Because as we know, there are companies with a big capital, so they have a large amount of money which can invested to use to apply automation, fully automation. You can imagine. I will show you later about the fully automated production line. So they have a lot of capital which can invest a lot of machineries, automated machineries, just like robotics and automatic conveyors and so on. So they can produce goods at mass production. But there are also companies who have very small capital or less capitals. They have to adapt a semi-automated or manually operated manufacturing system. Okay, so here we have a system in manufacturing. So what are the systems? There are subsystem or a small isolated system in the manufacturing. What are they? Okay, so the first one is a manufacturing processes. Of course, if we have manufacturing, we have processes. Can I check with a student here? Have you learned about the manufacturing process? Just check.
Ayo, ada yang mau menjawab ini? Adik-adik yang hari ini datang, ya. Jadi some of you want to answer the question of Dr. Farid, ya. Do you know the manufacturing processes? Atau they already know, ya, the processes, the manufacturing processes.
Dr. Wi,
yeah.
Students here, the attendees here, are they from the first year or the third year students, the final year students?
They combine from the first year until the fourth year.
Okay.
Yeah.
Yeah, I believe that the fourth year can answer this. The first year is acceptable.
Yeah.
Okay. So we have manufacturing processes. Yeah. For example, we have a casting, material removing, just like CNC machining. Machining is one of material removing, and then nowadays we have the famous one is additive manufacturing, rapid prototyping, rapid tooling, that kind of thing. Those are manufacturing processes. Okay. And then they have their own system. Every processes have their own different system compared one and another. And then we also, once we have a manufacturing process, we also have material handling, because of course when we are going to process goods, we need to handle that that the materials, right? We want to transfer or shift a material from one place to another, from A to B to C until Z. We need material handler. So one kind of material handling is just like is the conveyor, and you also have the quite advanced is the robots. Okay, so that's a material handling, and it also have their own system. Robotic system is different compared to the injection molding system, for example. They have own specific systems. And then when we have process in the factory, you can imagine in the factory we have raw materials, we process it, we undergoes a certain checking. Then what happened? We will store it before we ship to the retailers or to the customers, right? Okay, so that's why here we have storage and retrieval. What is retrieval? Okay, so it's simple. Storage means we store. Retrieve means we retrieve. We take it out from the store. So we put in and put it out. Okay, so this is a simple definition here. And then we have, of course, if we just produce goods, if there is no quality, so it is not, it is not acceptable for the customers. The customers is complain if the quality is low. That's why another department in the factory, in the production line, basically we have quality and inspection department. So here we also have a certain system for example, automated inspection system. We use digital camera to check for the quality of the product, produced goods. And finally, we have purchasing system. So this is, I believe this one is a part of the manufacturing, but it has less materials, less material, less machineries, but it involve a lot of documentations and softwares. So this is also a system, because why it's will links to the storage retrieval system, to the production, as well as quality and inspection. So this is the purchasing. It's part of the manufacturing system. Okay, and then this is the basic one, manufacturing. Then in late 80s, okay, late 80s or early 90s, the adaptation of new technologies has changed. Okay, you can imagine who have born in the late of 70s, I believe they have experienced how the Windows change, how the computers, our computers technology changed from word stuff, from what is called that Excel. Is long time ago there is no Excel in words. Okay, and then they have another type of operation system or OS, and then they have changes. But the computer starts to boom in 80s, late 70s and 80s. Okay, and as well as internet also have been started to develop, but is not worldwide adapted by industries and consumers. It's later on. So we go to history for manufacturing a little bit here. Okay, then we can imagine last time computer is a very big, very look tough. Okay, we have big workstation, but now as you can see, your computer, even you can do a lot of things with your small phones, okay, small cell phones. Okay, so that's the changes of the technologies. So in the late 80s, basically smart manufacturing and agile manufacturing concepts has been coined for the first time. So this Schaffer in 86 and Ismail and Sagu 96. For example, this is some of the references that had coined the term of smart manufacturing and agile manufacturing for the first time. So it's late 80s. They started to have the idea about the agile manufacturing and smart manufacturing. So there is actually is quite some times ago, yeah. But they still been always discuss and do research with smart manufacturing and agile manufacturing because the changes of the technology behind it. Okay, we'll go later about it. Okay, sorry, Dr. Vivek can stop me if I have, my time is finished.
No. Still long. Yeah.
Okay.
Don't worry, doctor.
Okay, and then we go from manufacturing, we go to smart manufacturing. So what is the definition of smart manufacturing? As I mentioned before, smart manufacturing have been coined by Schaffer in 1986 in his paper. But later on, it changes due to time according to changes of technologies behind it. Okay, so the definition given by National Institute of Standards and Technology, based in US, it is a US-based agency that control the standards and technology, that which the short form is NIST. Smart manufacturing can be defined as a fully integrated, collaborative manufacturing systems that respond in real time to meet changing demands and conditions in the factory, in the supply network, and in customer needs. Okay, so there are a lot of keywords here. Okay, let's me explain one by one. First, a fully integrated collaborative manufacturing system. That's why I mentioned before the manufacturing system. How important is it, right? Okay, here is proven. Why collaborative? Because as I mentioned before, in here there is a lot of small subsystem or systems in manufacturing in the whole. Okay, there are a lot of different systems, so that's why they last time in conventional manufacturing, those systems are not integrated and work collaboratively, but by using the smart manufacturing framework or concept, they started to think about it, and why don't we fully integrate it, or we work it as a collaborative manners to produce products. Okay, why we need to do this? Because we go for another keyword, respond in real time to meet changing demands and conditions in the factories, supply network, and in customer needs. Okay, so it's want to respond in real time to meet the changing demands. Why? Because in the end, we will go to the customer. As I said before, business and manufacturing is just like a coin. We have two different sides, two different faces. Okay, but in one item. Okay, customer wants this, and as a manufacturer, you have to produce what the customer want. Otherwise, nobody will buy it. Okay, that's a general understanding. Okay, so that's why if the small systems are not fully integrated or collaborative, what happens? So the production line cannot meet what the customer needs according to the standards. Okay, according to the standards, according to the satisfaction of the customers. Okay, that's why we need, because when we want to produce, sometimes they want a fast action. That's why here we mention real time here. Okay, and the changes have changed very fast. Okay, so this is the comparison between conventional manufacturing and smart manufacturing. So on the left side, on the left this diagram, so this is the general framework in a diagram form, in a graphical form, where we have a raw material, we have factory, in the factory we do all the processes, all the system run in the factory, and then finally they produce the goods, the finished products. Okay, that's simple. And then it's up to the marketing, sells the product, and that's it. Okay, it's up to them. Okay, so what happened if they have a new technology, a new products design, and so on? The cycle it goes as it is. Okay, just one line of cycle. But when they apply a smart manufacturing, okay, when they introduce a smart manufacturing, the game has changed. The situation, the scenarios has changed. It's different. They need, here on the right side, as we can see, we have the same raw materials, but the factory have changed a little bit. I changed the diagram. So it shows the factory system have also changed, and they have integration communication between retailers. Here we have internet, we have website, and as well as we have consumer or the buyers. Okay, so there is a changes of information with different directions. Okay, let's say the products goes to the retailer from the factory and then received by the customers. Customers buy it from the retailers, from the malls. And then what happened now, they are focusing more on feedback. Okay, more on feedback. Initially, they just focus on feedback, but now once you just go through the Google, you just Google anything, automatically they know you are finding something. Okay. Okay, and then here when the customer have bought the items, the system has changed. The factory or the manufacturers, they ask for feedback. Okay, feedback from the customers or from their retailers. What happened? So that's why they fortunately the internet appears, and this is the right medium for everybody can give feedback, give the information and collected by the factory, so they know what happened, what about the product acceptance from the customers, what are the actually problems when we want to deliver the products. So that's all things that are going to be studied, collected and analyzed. Okay, so that's the difference compared to the last one. The last one, I believe there is a feedback, but the process is not totally fully integrated as smart manufacturing environment. Okay, when we talk about the demand from customers, just now we look at the definition, right? The customer needs. Okay, the demands, changing demands, customer needs. What are these terminologies mean? So basically, products, as we know, always changes, right? Because of a lot of things. The first one is perhaps the material have changed, so you change the product. And then the second one, the manufacturing system itself, the processes, they have improved the process. So again, they change the product, become a better one. You can imagine last time we bought a car with carburetor. I'm not sure whether the younger students still realize what is carburetor, but then they changed to injection system for a car. That's why they call it as a internal combustion engine. They use when they want to spark to drive the engines, so they're using a sparks from the injection system. And then now they have changed to electric car. So we can see how the technologies improve the product, right? Have changed the scenario of the product. The technology change, and of course manufacturers have to follow what happened to the global changes. Okay. Then that's why for every product, basically we have what we call product life cycle. They have its own lifespan. Okay. At one time, along as I mentioned. Okay, as I mentioned before, last time we use car with carburetors, but now they've changed. Last time we use we drive a motorcycle with clutch, right? But now, sorry, motorcycle or car with clutch, but now most of them are automatic. Last time, four-wheel drive car and two-wheel drive car is different, but now they can integrate those systems in one car. So this is the example of a product life cycle. They change the product, and then they create the new one, and what happened basically when a customer doesn't want their product anymore, so that's why the production will goes down, will decline. Okay, so here in the diagram on the left side shows that there are, for a product life cycle, there are few level of few stages of process. Okay, three stages of a product life cycle. The first one, research and development. So in this part, in this stage, basically the product haven't developed yet. It just have a general idea. So the engineers, the scientists sit down together and try to develop the products. Okay, and then what happened? At this moment, there will be a lot of prototyping, or pilot sales and so on. Then it goes to introduction. The numbers of sales on the left axis, you can see the sale. On the right axis, it shows the timeline or the stage for the product. And then during the introduction, there were a lot of introduction sales. I mean, let's say the car, for example, when they introduce a new car model, what happened? This is the initial state. They do marketing, a lot of marketing. They do a lot of foundation works they do a lot of studies for the production line. For the more complex products, will have a complex production line. Car, for example, car or motorcycle. And then here what happened, the sales increase. And once people accepted the product, okay, so let's say people now can accept hybrid car with IC engine as well as electric motor. So there is a growth. Okay, when there is a growth, the number is increasing exponentially. It starts to increasing exponentially. And finally, at one stage, what happened to our, okay, another good example is cell phone. Yeah, cell phone. Now we have internet phones. Yeah, internet or smartphone. We have internet. We have a lot of apps. So now for the handphone, it is a stage 3, and it's still developing a new one, and then it grow. But what happened to the old phone with a lot of text buttons, and then with just a black and white displays? What happened? It become already declined. Okay, it's not matured yet. Already, I believe it's already declined. The matured product nowadays, for example, the phone with standard internet, with a camera. Now they already introduced a phone with 3 camera and a lot of AI technologies adaptation. Yeah, for the last few years, there is no handphone with 3 cameras. So what happened to the single cameras? It's already in maturity. Okay, and the price also become cheaper. And then what happened to the old kind of phone technology is declining. Yeah, and finally nobody will know what is diskette. That's one example. Everybody, when I said how many of you knows about USB, I believe most of you, okay, can raise up your hand, and then you say, okay, I know what is USB. But when I say what is diskette, what is cassette, I don't. What happened? I believe for the youngest, they don't realize what Dr. Fai is talking about. Okay, on the right side, here is a diagram. How many of you can guess what kind of machine is this? So this is an example of a decline products. This is basically, anybody can guess what is this? It's a washing machine. Washing machine. A long time ago, they create a washing machine like this. Okay, there is a tumbler down there. There's a container which contains a tumbler to rotate, to wash, to do the washing, and then to spin. There is no spinning. So if you look at the top of the machine, there is a mechanism, just like there is 2 rollers there. So this is the spinning process. So they take out the water using this technique. Okay, there is no spinning. Okay, so this is the old version of washing machine. See, in fact, I also haven't seen this this kind of washing machine. So this is an example of the decline machines, decline products. So they put it into the museum. Okay, then back to the smart manufacturing. So that's why I want to show you the product life cycle. I want to relate it with the definition of smart manufacturing. Fast response, very responsive, and then fast changes demands. All these kind of thing have affected the production or manufacturing. That's why we are going to be a smarter system, smarter manufacturing production line. Okay, so if we look at the ecosystem, if we look at the bigger figures about smart manufacturing here, we will see there is a lot of integrated systems here. We have the production itself. So during the production, we have designing process, we have building process, development. Building means development, and commissioning. Commissioning is ready to market it. And then we have some technologies like CAD, CAE, computer-aided engineering, computer-aided design, CAM, computer-aided manufacturing, that helps the process, the design process, the building process, and we also have a simulation. Next, we have another branch. We have design stage, the DFS, the product, focus on the product. This one is production. This one is product. It's different things. Product is the product itself. Phone is a product, but production is the production line. So it's different. So for product, they also have a product design, also include applying the CAD and CAE technologies. They have process planning, plan how much product to be can be produced. They do some anticipation, prediction. That's what happened in the process planning and the production engineering. And there also one branch for business, because the business will get information from the customers, the consumers, all the data they share. As you can see, there is a lot of arrow, yellow, orange arrow here. So there is where the data changes, okay, move all around the departments. And then they also have digital factory, decommissioning and recycling. And then they have a recycling. Now, recycling is a new thing for sustainability, because it's a general issue, worldwide issue now, global issues. So that's why in factory now they also have decommissioning and recycling products. They have that department or teams to do that. What happened to our bottle, for example? What happened to the car battery? That we introduce electric car nowadays, but what are the waste from the cars? For the old one, they have engines, they have a chassis, they have a tire. But now for electrical car, there's another things that will become a waste for the car, basically batteries. So what happened to the batteries? What happened to the old cars? Why we want to do it? So this is the commissioning and recycling the product. So there's one department about it who look into the how to study, to analyze what are the impact of the product to the environment. System, bigger view about. So the information, the feedbacks is all around, from the internal side to the including, as well as from the outside. Okay, from outside of the manufacturing environment, and which I mean the retailers, the customers, consumers, the governments, and so on. Okay, and then what are the technologies behind it? Okay, artificial intelligence, expert system, industrial revolution, IR 4.0. Okay, this one I explain more about this. Big data, including big data analytics. Everybody's talking about this now, especially for the businessmen, manufacturers, as well as people in the coffee shop. They will talk about it nowadays. Internet of Things. And then in communication, we have nowadays in Malaysia, for example, a lot of 4Gs, of course, but 5Gs is quite still in introduction stage level. Okay, 5G communication, mobile internet. Okay, for 5G communication. Last time we have nowadays we have 4G, but for advanced countries, they already implement 5Gs. Okay, and then we have robotics or other manufacturing techniques like additive manufacturing, rapid prototyping, for example, rapid tooling. So these are the technologies, and each of these technologies also evolving on itself. Okay, for example, the communication. Last time we have 3G. During my studies in degree level, there are 3Gs. 3Gs. If your phone support 3Gs, you are up to date students at that time. Okay, during my age. But now nothing nothing to do with 3Gs. We have in 4Gs and everybody is looking for 5Gs. So this is an example of the technologies behind the smart manufacturing is also evolving. As well as the internet. Last time internet we just use for chatting, we use for surfing, get informations. But now internet is not only for getting information, but have been evolved to share data and then to trigger data, to share data, to collect data, to trigger data, to ask the another subsidiaries what to do. Okay, the internet becomes more complex. In fact, nowadays data is important. It's not a requirement anymore. It's not a requirement. It's a needs nowadays. Okay, if there's no internet, you can't. It's quite difficult to study, right? And internet also have linked us together. For example, today in Malaysia and Indonesia, so we have class webinars like this. So this is the advantage of internet. So it's become a bigger responsibility. Okay, so this is a technology behind the smart manufacturing. Okay, and then smart manufacturing characteristic, digitization of every part of a manufacturing enterprise. We have manufacturing enterprise, business. Okay, this is a business part. So now when we use internet, of course, we change to digitization. Okay, informations translated or the informations are represented in digitals. Okay, that's what happened because we change it to data. That's why we need to change it into digitization. And then connected device and distributed intelligence. Last time when the system, back to the definition, when we apply smart manufacturing, of course, a lot of subsystems are connected, integrated, fully integrated. Okay, so including device. So for a small system, of course, they connect smaller device or smaller system into a bigger system. But for manufacturing as a whole, is in a bigger pictures, they connected from one department to another department. So that's what this means. And distributed intelligence, they also change. They also distribute the intelligence, the decision, for example, the way how they think. Okay, for example, is this motor ready to be changed after 1 million cycles, for example? Is this machine need to change its rubber O-rings or belting, for example? This conveyor need to change the belting after few cycles. This bearing, we need to do the what we call that, we put the grease inside it. Is it time to put the grease in the bearings, for example? So this kind of information intelligence are distributed well. Okay, so that's characteristic of smart manufacturing. For maintenance, for example, this system, they will inform the engineers, they inform the technicians, and in fact, not only the engineers and technicians know when to replenish grease in the bearings, but also arrive to the managers. How many in manager side start to think about business and about the costing. So okay, so is that okay? I thought there's a question. Okay, and then in fact, for the managers, they are looking for costing. So he or she also know about how many parts have changed, how many parts to be changed. So because as a manager, he or she will plan for the budgeting for the company. And then collaborative supply chain management. And then, okay, you can imagine last few slides I show you the different the definition of manufacturing is converting raw materials into products, right? But it's not as simply as that. Basically, if we're looking into a deeper real environment, manufacturing environment, there is a lot of another in the manufacturer. There is another manufacturer that supply products to be assembled in the final manufacturer. For example, car or motorcycle, the tires are not produced by the brand of the the companies of the car or motorcycle. For example, I give you one example. Toyota, for example, Toyota not develop the tire. Of course, the tire we have another brand, right? We have Michelin, we have Continental. I'm not sure in Indonesia the name must be quite different, right? And then in fact the model of the car also changed, right? What I heard, yeah, you have for example Kijang, right? Kijang. What I still remember when I was there. Okay. So Toyota produce cars, but Toyota have several vendors. We call it as a vendors or support collaborative manufacturers. So in this case, they have a supply chain and collaborative supply chain. Let's say Toyota assemble the cars to produce the final car, do the testing and shipping. What happened before that, there is a company that will cast the engine, for example, fabricate the engine, fabricate the transmission system, assemble the gearing system. Okay, so it will be the different companies. Perhaps it is subsidiaries of Toyota, or it could be companies that no link, is not a subsidiary from Toyota. It's a different companies, but it still produce products and supply to Toyota. Okay, so that's why I said it's not as simple as converting raw materials into final goods. That's why when it's become more complex, that's why they have a supply chain management. They need to manage the supply chain between the vendors, from the raw material suppliers and to the retailers. And integrated and optimal decision making, this is also one thing is important for smart manufacturing. That's why we put it into as a one characteristic for smart manufacturing, which is if you have a bad decision making, that's why your production is very slow and not responsive, not agile. Okay, agile means how they respond to the customer requirement, customer needs. Whatever the customer wants, and then they change. Okay, for example, this seat is not so soft. This is a bumping material, for example. Okay, so we need to change to a good material. The silicone is very flexible, but for example, rubber is good, but it's quite heavy. Silicone is lighter. Okay, so this kind of decision must be made in a smart manufacturing according to the customer need. Okay, last time when I visited Indonesia, I was in Bandung, and then I visited small and medium industries there for a textile technology. And then we went to Lang Buana University, if not mistaken. Okay, so Lang Buana, right? So there, we learned that what happened. There is for Bandung is a very known, especially for Malaysians, for textile, right? Prior to COVID, many Malaysians go there and then buy shirts and clothes from Bandung, in Bandung. Okay, so what happened? Let's say for the textile technologies, so the manufacturers knows what are the demand for the certain countries. For example, in Malaysia or West, for the Arab countries, which are very hot countries, so the material is different. It would be polyester or cotton. See, But for countries that there's a for climate, for example, for the winter countries, for the Europeans, for example, the material have changed, the combination, the composition of material change, and in fact, the thickness of the fabrics also different. Okay, so that's the example of how we want to do the decision making. Okay, and then advanced sensor and big data analytics. This is also one of the important characteristic for smart manufacturing, because as I said, in smart manufacturing, there is a lot of data distribution, data movements from supplier to vendor, vendor to the customer, and internet is the medium. So at certain point, sensors are required, especially in the production line. They need sensors. For customers, I believe there is no sensor. They just key in their phone and computer, everything obtained from through the internet, whatever the customer want. But when it goes to in the factory level, what happened? There's a lot of sensors to bring the data out. So the manager can analyze, the engineers, managers, the CEOs can analyze what happened. They want to do the planning, they want to do the production line to make a decision. So there will be a lot of sensors. And big data analytics, of course, if there is a sensor, there is data, we'll go to another level, which is how they pull the data to get the data. Okay, and then they need to process the data. They can cluster, because let's say if we are doing entrepreneurship, right? Because what happened, the entrepreneurs will use the data from Google, for example, to classify, to do the market segments. How many of you like fishing? How many of you like riding cars? How many of you like go for touring? So this is how they distribute all the data, analyze and distribute the data. And of course, it also includes a data security. Okay, this is an example of smart manufacturing and smart factory. This is the one of the example of the organization in factory. So basically, we have a CEO, we have manufacture. We have departments, bigger departments and smaller departments, or small subsections. For example, here we have manufacturing departments, we have sales and marketing, and also purchasing. And then under the manufacturing, there are production, new model development. So this one will do the R&D. They have a quality and production planning. So it's the different type of function and section in the manufacturing department. So this is just example. Don't say this is the final one everybody uses. No, this is just example. There is a hierarchy, there is a this department distribution. This is one our case study from, because I got it from Mr. Nazri Ahmad from Honda Malaysia. So just sharing with you guys. So this is just a example, one example how they organize their factory. So the information is not only for smart factory and smart manufacturing, the information is not only delegates among the lower level, but it also can be assessed by CEOs and the head of department level. Okay, the technologies behind, for example, here we have 5Gs, how the 5G works. So they have production line, they have the okay, and then how the smart factory applies it. It gets all the data from the plants, and then they have a 5Gs work as a collectors of the data, and then they have a data lake or pool of data. They collect the data, and then they have another department to do the analysis. So whatever happened in the production line, they have 5G elements, devices, they send to the control center. So from there, they can do intelligent to make a decision for the production line. And then for this is for the smart factory. If you are looking for a bigger scenarios, a bigger picture in manufacturing, so it's including the cloud, for example. So as I said, we have vendors, we have main manufacturers. Okay, and then for example, I will show you example later on. There is a company from Malaysia which is a vendors to a bigger company in China. So what happened? They use cloud, they use data lake to collect the data, and whatever they produce in Malaysia can be seen in China. Okay, so this is one example of our, what I can say, this is a small and medium enterprise, small and medium industries. It's not a bigger one. This is set up in Johor. So this is a production line, for example. So as you can see, it is a normal production line. There is a lot of machine, a lot of structures, and then there is a material handling. There is a conveyor here. It's not seen well, but there is a conveyor here to change from one station to another station for installation and testing. So this is a normal production line. You produce product from raw materials, assemble, test, and you pack at the end of the production line. So basically, if you look at it, there is no different things, but the difference is they just add on the IoT devices. Okay, they just add on IoT devices to the production line. So all the data process in the production line will be collected and recorded and analyzed. Okay, this is the example of the company that I said before, a company in Johor. So this is a vendor company. They cast and machine parts and send the parts to China, the main company. So whatever happened inside the this company, let's say how many reworks, how many work in process, all the data are recorded and can be known by the main companies. So this is, for example, the cast part. Okay. Because why it is important? Because everything, the information that the customer wants, they can send all the information that quickly to the vendors. So if they want to change product, they will ask the vendors to do what is the planning. They will explain the strategies for the manufacturing. So as you can see, it's just a simple factory, but they already implement the IR 4.0, the IoT things. Okay, this one I took it from Adidas website, the new technologies and processes. Okay, other than application in SMEs, SMI, we also look at the product itself. So for product itself, new technologies and processes also change the game of the manufacturing strategy. So in this case, what kind of technology is here? Last time when we make a shoes, we use injection molding for the this lower parts of the shoes, and then this one, of course, I believe they use a fabric, right? They cut fabric and then they stitch it and become a shoes. And to make it a shoes, they using glue for the lower part and the upper part. But now Adidas, what I like about this technology is they combine new techniques, weaving techniques for the upper parts, and the lower parts they use rapid prototyping technique to produce the shoes. But what they claim, Adidas said, it is faster use this technique compared to the previous one. Because I'm not the shoes manufacturer, but from what I believe is perhaps there are the different vendors or different departments where the processing time is quite long for for the old techniques. So that's why Adidas produce a new technique, and of course it's not only about the combining these two parts for the shoes, but it also change because of the requirement for the customer, where when they use these shoes for running or for walking, for example, they need a special structure like this. So to produce this structure, they cannot use the old techniques. They have to use the new techniques. In this case, they use rapid prototyping technique, rapid manufacturing technique. Okay, this is another example of new technologies and processes. This one I take it from MIT News. Okay, nowadays it also is a lot of studies for smart fabric. Yeah, they put a lot of things, a lot of sensors in a fabric. What is the application? Basically for sports, for for health, for health rehabilitation, for patient. For example, they want to check their pulse rate. They want to check for their temperature, body temperature, moisture. So they embed, or they already embed sensors inside the fabric. So this is also a new technologies that change the final product. So this is how smart manufacturing is important. Yeah. Okay, there's another example. So they have a new machine with IoT internet devices that can share informations. A lot of systems are integrated. Why? Because they want to produce more complex parts according to what the customer needs, and the use of a material handler. So on the right figure here, diagram here, is shows about material handling using a robot, and also they have integrated with part tracking. They're using RFD. This one developed by Mitsubishi Robots.
Excuse me, Dr. Farid. I would like to remind you about the time. You still have 5 minutes left, Dr.
Okay.
Yeah,
Okay.
thank
you. Okay, this is an example of automatic storage and retrieval system, ASRS. So we just put key in information. We know using the internet and IoT inside the manufacturing system, we know what are the products kept in the storage, and how many products are retrieved and how many products are stored in the storage. This is another storage system, ASRS, automatic and storage system. Okay. Okay. Before we go for conclusion, this is the gap. This is the general gaps towards the smart manufacturing. What are the problems? So in the end, the ideal idea is to have the industry 4.0. For example, they have self-configuration, self-optimization, decision making, good decision making. But there is a gaps between the existing environment here. It depends on the countries. Okay, it depends on the technologies provided by the countries. The third world countries are different with the advanced countries. Okay, so in manufacturing concept, they have a preventive maintenance, real-time responsibility, customization, flexibility, digitization. And here we can see what happened. There is a state at a different level of the current manufacturing system. In current manufacturing system, they divided into single station automated cells, assembly, flexible manufacturing system, computer integrated system. So in this study by Keane and his colleague, what happened? So this is what happened. There is a gap. It's quite high gap, but the gap can be divided into certain manufacturing system. It's not all, but for example, the reconfigurable manufacturing system, the gap is quite low, but for the higher one is the automated assembly system. Why? Because a lot of things. One, for example, let's say the company have invested a lot of its capital to set up a production line, automated production line, which is very, very costly. And then they have to change because of the IoT, because of the IR 4.0. So it doesn't make sense. Of course, the decision level, the board of directors will think a lot of it. Either we want to spend a lot of money for rebranding, reconfigure our automated assembly system, or just leave it like that. So this is a debatable decision. So this is one of the example of the gaps that occurred to the companies, whether they want to achieve a smart manufacturing or not. and it depends on the type of the companies, whether it is a SMI, small scale companies, or big companies. So the conclusion, new emerging technologies stimulate the evolution and adaptation of smart manufacturing, like AI, like expert system, like IR 4.0, Internet of Things, and so on. And the implementation depends on the nature of production, business ecosystem, and okay, and the country itself. Okay, the country which provide the facilities for the area, industrial area. And then the challenges, the issues with compatibility of the existing machine and system with a new technology. As I said before, is it possible to adapt this smart manufacturing with the new devices, new technologies? Because of course it will increase the cost, but the returns, it depend on the management to see whether it is acceptable or not. If the return also is quite high, so it's okay. You can proceed to adapt a smart manufacturing. So this is the challenges to the manufacturers. Okay, so just nice. I have just finished my presentation. So I return back to our moderator, Dr. Wiwik. Thank you.
Thank you very much, Dr. Farid, for your informative and interesting presentation about smart manufacturing. Yeah. For the audience, if you have any question regarding to Dr. Farid presentation, please hold it on, yeah, because we will continue to our second speakers. But before we move to the next session, please give a big applause for Dr. Muhammad Farid Saari. Thank you, Doctor. Now we are going to our second discussion with Associate Professor Dr. Muhammad Mozassar Rahman. Assalamualaikum, Prof. Mozassar.
Waalaikumsalam.
Okay, thank you. Yeah, nice to meet you today, Prof.
Welcome.
Before Prof. Mozassar deliver his presentation about smart manufacturing, I would like to read the short CV of him first. Yeah. Associate Professor Dr. Muhammad Mozassar Rahman, Chartered Engineer, Professional Technologist, is a lecturer in Department of Mechanical Engineering Technology, Faculty of Engineering Technology, University Tun Hussein On, Malaysia. He was born in 1966 and got his Bachelor of Science Engineering from Department of Mechanical Engineering, Bangladesh Institute of Technology, Khulna, Bangladesh, with a first position result in 1988. Prof. Mozassar then continued his study in Japan. He finished his Master of Engineering degree in Mechanical Engineering in 2000 and got his PhD in Systems Engineering in 2003, both from a Graduate School of Engineering, Mie University, Japan. Associate Professor Dr. Muhammad Mozassar Rahman research interests including human-robot cooperation, rehabilitation robot, autonomous system, industry 4.0, machine and mechanism. Yeah. Moving along to our second session, please welcome Associate Professor Dr. Muhammad Mozassar Rahman. The time is yours.
Thank you very much for short introduction of me. Okay, so I also very excited to be here because actually the is a cross country, that is international, and due to you look at this, the COVID-19 also give us some opportunities of like to broaden our the knowledge, broaden our use of technology to our in daily life, and then actually can you see my slide?
Yes, Prof. Clear.
Okay, so I will not take too much time to you because most of my the thing already covered by Dr. Farid. Okay, so I will not introduce you. Actually, I want to inspire you, to motivate you to use the industry 4.0 in our all the possible level. Because you see the old people like me, we also still have a fear about the smartphone, and many of the old lecturers, they fear about this computer, because when I graduated in 1988, I even not seen any computer, not seen. After my graduation, my institute, but when I joined as a lecturer, they bought a computer IBM 86 machine. Maybe today's is like in the museum. And that machine was inside a glass house. In a room, inside a room, there is another glass house. Inside the glass house, that machine, it price maybe nowadays few $100 that the machine cost, but that time it was a few $1,000. Okay, so that was the computer. That's why we are very afraid about the using the computer, smartphone. Sometimes we mishandle it. But the new, the young generation, they are actually we call the used to use this all the new technologies. That's why all the old, the owner of the small industry, medium industry, they're afraid industry 4.0. They think, oh, for industry 0, it is for German, it is for Japan, it is for USA, it is for the Korea. It is not for Indonesia, not for Malaysia, not for Bangladesh. We have nothing. Don't have anything. Why we go for the industry 4.0? 4.0 they invented in Germany and they are using this. We are unable to use this. So today I like to just try to motivate you that actually we can use the 4.0 from today, from tomorrow in our factory. We can start now. Okay, so how? Okay, so why is the matter? Why the industry 4.0 is matter? Okay, so let me. Today's agenda is here. So industrial evaluation. So these are the, but I will not go all through these because the timing constraint. You see, before the industrial revolution, this is the the flour mill, hand mill. So we can put the bean or the wheat or any of the thing, and you can just hold the handle and round it. You will get the powder. Then it changes to here. Okay, the water power we just replace the the human power, water power. So this is also a water mill, the mill, but using the water power or the wind power, windmill or water mill. Okay, then after electric, you also, I am not sure whether this is still in Indonesia or not. In Bangladesh, some places still they are using this one in the rural side. Okay, this one is the automatic, the rice, the automatic flour mill. So now is everything is going automatic. You just the washing, cleaning, then the husking, and then grinding, everything, packing, everything is there. So this also available in Malaysia, in Indonesia, in Bangladesh, all the third world country. This also available. Now here. So here the some are the player is on the track, and the million of the audience on the they're looking to there. So now it is the time to decide whether we will be on the track or will be on the seat to only see the whether the Japan, the USA, the German, and then the Korea, they are running and we are enjoying. Or we want to compete, we want to track. Okay. Sometimes we say, oh, it's very difficult. Okay, now look at here. So this figure, what is this? The game. This is the game. Some Game Boy or game. Then the TV. Then this is camera. This one is the tape recorder. Then the phone. Then the radio. I think all these things nowadays almost in the museum. And then you can see this one is the all, not only all. And then additional thing also there. Lot of sensor is there. The navigation, I didn't put the something like the remote controller, then the navigation, and then your temperature sensor, and then the many other things also now included in one device. So, and then again, okay, so I just this, the screenshot. So now why this? Because now this changing. All this, the thing is actually changing from this, from the customer. The customer is now the more sensitive to the product. They don't want to the product, and also factory also don't want to the produce lot of product to keep in the warehouse, and customer also not satisfied with the prototype product or the same product. They want their own customized product they want. That's why actually we need to go. Okay, then if you look at here, the stages, we are now talking about this industrial, the revolution IR 4.0. Actually, is a new term they use. Before that, actually, we don't have any term industry 1.0, 1.2.0, industry 3.0. No. Actually, after this word is started, then we put this industry 1.0, industry 2.0, industry 3.0, like this. Okay, so when the human power, they actually, the changes to this another mechanical power, then actually use the like water and steam, and then that is called the industrial revolution. And then the industry 2.0 or second industrial revolution is using the the electrical energy, and then electricity, and then the electronics, and after that is and also mass production is here. Then after that, using the automation and the robotics in 15th. And then now is the industrial revolution based on cyber physical system. This one is the two things we need here still in the factory. Until the industry 3.0, we were inside the factory, but now the beyond the factory, that this is called the cyber physical. The factory also there, and then we need to think about the cloud. We need to about it's called the cyber, it's called the cyber world. The cyber world also we need to include here. Okay, so this again come to this. This was also a cell phone first when it started to this the wireless phone, or this cell phone technology first introduced in I think the end of the 80s or beginning of the 90s. That time the price of one of the set was around that time, if I remember, it is around $3,000 to $4,000 US dollar of this set. The cost of this set or the line connection, etc., everything is so now you can buy a SIM by 10 ringgit in Malaysian ringgit, 10 ringgit, and a set is 200 ringgit. Yeah, there are costly. Some of the telephone set is costly, but you can actually buy a very this is the 2,000, 3,000, or sometimes the $4,000 US dollar. But now you can buy less than $100 US dollar a smartphone, And this one was only for talking, but now your smartphone is. So that's why actually, okay, you can see this the Shopee. I say I took the Indonesia Shopee.com.id, then the Grab.com.id, the Indonesia. So how many shop and factory Shopee belongs? Your answer will be no. Shopee don't have any shop. Shopee don't have any factory, but they are selling millions of product every second. Million in Malaysia, in Indonesia, in Thailand, in Philippines. The shop is selling million in China. They are selling millions of the product in every second. And then the Grab, how many cars they belongs? Also answer will be no. The Grab, they don't have any car, but they are what's called the ferrying, or they are also the riding or passenger. They are conveying the passenger. All over the world is million of passenger there without any car. So that's why actually if you have a factory, you don't need too much thing to implement the industrial regulation or IR 4.0 in your factory. You can start from the today is the plan it and then go for it. Look at the timing. So 80 years. So 1760 to 80. So these are the timing. That means 60 to 48 years. Then 70 to 40 is then you have 70 years. Then 60 to 70 is 50 years. And now after this 2010 to now we are 2021, I mean 10 years. So after 10 years, almost we are going to implement the 4.0. In some of the country, they are already implemented. Okay, so this was actually the word, the industry 4.0. This word is in the start, it is from Germany, the Smart Manufacturing Leadership Coalition in USA. Okay, so sometimes we call it the smart factory, but it is not only the smart factory. The vision was the smart factory using the Internet of Things, Internet services, but now is cyber physical. Try to keep in mind the cyber and also a physical. A cyber system, also physical system, is going together to be a new era of industry, that is industry 4.0. Okay, in 2006, no iPhone. Before 2006, no iPad, Kindle, 4G, Uber, that Airbnb, okay, and then Android, and now, okay, so time to reach 100 million customers. Time to reach 100 million customers for the telephone, it took 75 years, and web 7 years, Facebook 4 years, Instagram 2 years, Pokemon Go 1 month to reach 100 million customers. If you look in other the product or something, you can see how the technology or how this the Internet of Things or something is actually accepted by the people. Okay, cyber physical system. You can see there is the computation, control, communication. Okay, so these are all these things together. Okay, because lot of computation. Because if okay, so now if a person want to think that I want to make my own platform for selling the good, like Shopee, I want to make a platform. Is it possible for a small, the shop or small a person or small, the factory, small seller? Not possible. So what actually he can actually just use the platform Shopee. No need to make his own platform to sell the product online. He can use Shopee and many other things actually. That's why this cyber physical system, that's we call the big data. I will show you this big data. That means that in the platform, the manufacturer, they can actually buy some IoT product, and then if needs some automation, the system, and then they can actually convert their factory to the IR 4.0 factory. It's in the cyber, it's called the smart factory, and they actually will be a part of the IR 4.0. Okay, so I think is already covered by the these are the six the six design principle. So I also try to solve. Okay, so these are the what's called the building block or pillar of industry. So this autonomous robot, but no need to, if your factory some automation is there, no need robot. The automation already there. The simulation you need to, because actually the product variation, as the customer order in variation of product, you need to do some other simulation, and then horizontal vertical system integration. When they you need to a system with this, because the big data analytics to make your factory included all from the CEO to the the cleaner of your factory. You included all together, man and machine. Not only the machine, all the man, all the machine, all the everything, your the financial system, your transportation system, everything you can integrate together. Then you put some of the the sensor, which is we call the and some of the component that we call the Internet of Things, which is connected to internet. And then you have to, this is actually you can just pay some money for cyber security. And the additive manufacturing means actually your variety of product. Let's say you're making a furniture. So you have a different type of sofa. Don't make make the sofa, you design, you make the simulation, you design it, simulate it, okay, then keep the design and the post your design to Shopee. And then when you get the order, then you can make like this. Because all your Internet of Things, machine, everything will when the customer give you the order, it will make the simulation, and then it will actually the CAD, CAM, everything. He will the order, how much what are the raw material you need, which machine you need, and how long it need. It will simultaneously give you, and then by all this the information from here and from the big data, you will keep how long it takes to make, and then from where you get what you need to order, reorder the raw material, and how you need to go to transport. Everything will become, and then you can actually make your product. And if you need to this augmented reality, there are many software, even the your mobile, the apps is there, you can actually see. So you can give this the augmented the figure to your customer, and they can use the smartphone, and you can actually troubleshoot your product, your machine inside the customer house, and you are from maybe any other country, not only your factory, not in the remote, but you can any corner of the world, you can actually see what is the machine, and you can actually thus instruct your customer to repair, to assemble your product, everything. So that's actually the thing. Okay, this also the same thing is here. And then maybe these are the bigger picture, what all are included in the from human resource to engineering designs, sensor, actuator, everything, supply chain, everything is actually included in together. That's actually and then you no need to be all the thing with you. Your factory is with you, and then you use the other one person's one is to make your factory the this IR 4.0. I think now the there's are some example is here. So maybe I will share this presentation to you. So if you need, Dr. Farid also already told you about this. They are everything. Internet of Things is there in the everywhere. Okay. So there are a lot of the impact in economy. So if we want to actually compete with other and we want to survive, there is no it's called the way otherwise to adapt the industry 4.0. Okay, that's all from me. Thank you very much for listening.
Okay. Thank you very much for your valuable and interesting presentation about Industry 4.0, Prof. Mojasser. Yeah, and please give a big applause for Associate Professor Dr. Mojasser Rahman. Okay. Yeah. Discussing about smart manufacturing and Industry 4.0 is always interesting, yeah, especially what was just explained by our incredible speakers today. Yeah. Now we come to our question and answer section. Yeah, it is time to invite the audience participation. If you have any question, please raise your hand, unmute the microphone, mention your name before starting the question, and please identify the speakers to whom you would like to ask the question, and this must be done one by one. Or you can type your question in the chat box, yeah, in English or in Bahasa Indonesia. It's just okay. Okay, is there anyone who would like to ask the presenter today? Okay, we have Mas Rafiq. Yeah. Okay, Mas Rafiq, would you like to unmute your microphone?
Okay.
Thank you. Please welcome.
Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Thanks for the time. I would like to ask to Mr. Farid. Currently, smart manufacturing is no longer a complement, but it is a need, like you said. However, smart manufacturing directly causes reduction in employment because the position that was occupied by human can now be taken over by robots. This is the first problem. The second thing, smart manufacturing will also need expensive investment. And also the quality of the human resources in Indonesia actually is not fully evenly distributed. And thirdly, or the last one, smart manufacturing that relies on the internet connection will further increase the chance of the cyber criminal to infiltrate and steal sensitive data stored by the companies. My question is, how do we tackle all of these obstacles in implementing smart manufacturing? Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Mas Rafiq. So the question goes to Dr. Farid. Yeah. So Mas Rafiq is our alumni, Dr. Farid. Yeah, he used to be my student long time ago. Yeah, now he works in manufacturing industry. Yeah. In Semarang, Indonesia. So would you please answer his question?
Okay, thank you, Mr. Rafiq, Mas Rafiq. Yeah. Okay. Thank you for your question. And okay, as I said, it is, of course, it's a lot of debate about this. And the first one, smart manufacturing will make it the opportunity for the workers to to be hired is very slim, very slim. Yeah. So and then it also have it also will create a cyber security problem. So okay, in that case, that's why I said in my presentation before this, it depends on the policies of every countries, because in this case we have to look at these certain level, because for a bigger picture, for a bigger at a higher level, at the country level, because the only country knows how to protect the system, or the very information, the very sensitive information, by controlling the access to the internet system. Okay, so that's why there must be a team in the support, to the support team that can do the cyber security system. Okay, and then of course, because all the internets are basically they are connected between countries. Okay, for example, in Malaysia, the what I've heard, the main gateway for the internet in Malaysia has come from Taiwan, because it's a big cable, right? And then they interconnected all the cables to US and European countries who control the whole internet system. So it's for me, it depends on how the country can set the policies to develop the cyber attacks, because it always it occurs, and it already occurs, because because we have we have a lot of countries here, and then we have a different thoughts, and then different understanding, and so on, and then there because too many people in the world. And so that's why they have when they have a different intention, different agenda. So that's why there are opportunity to have cyber attacks. So to protect this, I believe that all the governments at the global level, international level, they can sit down together and do some kind of MOA, MOU, how to do the cyber security, how to develop the cyber security to protect for the benefit of the mankind. And then about the employees problem, okay, so there are a few models. What I believe that of course, when we apply automation, which is requires a lot of capital, as I have mentioned in my lecture before this. Of course, it will make the potential to work in industry for the local people become slimmer, so become narrower. So what we can do is, my suggestion, this is my own personal suggestion, we can develop the support technologies for the automation system. So for example, if we know that the basic one, sensors, so why don't if you want to set up a complete, fully integrated automation system in the production line, rather than we hire expertise, or we we just bought the system from overseas, why don't we slowly try to develop our own? Initially, perhaps, of course, we imported it. We just bought it because let's say we want to set up this production system. We just bought it and assembled everything here. But I believe a big countries, and with big market like Indonesia, you have the potential to develop the support technologies for the main automation technologies as well. For example, develop our own sensors, develop our own actuators, and we can learn it from developed countries. This is my personal idea.
Okay, thank you, Dr. Farid. Does this answer your question, Mas Rafiq, or you would like to ask more?
One thing I think still there, maybe I can add somewhere. Okay, so regarding the unemployment, okay, actually nowadays you can see the human, they are working like a slave in terms of even some people, they work maybe 16 hours, 12 hours a day. If let's say if we want to like because for our health condition, if you look at the health condition, is not good, because this, like I said, this COVID-19 give us this awareness. There's actually the medical science is not sufficient. We need to, the curing is not the solution. That health and a healthy body is actually the more, the important thing. That's why, so if we reduce the workload, that means if you now the eight hours is working, so we reduce it 4 to 5 hours to a people, then double people can actually work, because our purpose is to produce the sufficient amount of product so that we can enjoy that product. We can eat, we can enjoy, we can then wear it, our the clothes, we can live in a good house like this. So if we reduce our work, we can enjoy, we can play, we can actually do some healthy it's called the activities. That can be do. Actually, the problem, because when the industrialization is started, that time we saw the lot of the people will be unemployed. No, actually there will be more opportunity to do the work in the new the field of the work will be open soon, inshallah.
Okay, thank you for addition, Prof. Muzasser. Okay, back to Mas Rafiq. Does this answer your question, or you want to ask more to both speaker?
Yeah, actually, I'm agree with Mr. Muzasser. Yeah, actually agree. But if we see in the data in Malaysia, there is about 4.8 the jobless level because the COVID-19 actually. How is the situation regarding the smart manufacturing in Malaysia compared to Indonesia at this time? Actually, I just want to know.
Okay, I think the situation is almost similar or little bit higher than the Indonesia, because now Indonesia also emerging towards the many of the the foreign investor. They are trying to ship their the factory from some places like China to Indonesia, some from this is, that means the Indonesia is growing rapidly. And as I said last time, when I'm from Bangladesh. I came in Malaysia in 2000, the end of the 2007, okay, the 2008. So that time, so I have seen a lot of Indonesian workers working here, but now it's the number is very low compared to that time. That means they return, they have their job in the Indonesia. So they return to their country. That means the job actually I think the more job producing in the Indonesia, and it is the what's called the growing, the trend is growing. So in terms of the automation, so not too much, because as I mentioned in my lecture, that still the small and medium industries owner, they afraid about the cost. What the you also raise the question, the cost of this smart manufacturing, cost of the automation. But my question is that all the component, if you look at this smart manufacturing, or whatever we say the industry 4.0, the no need to be all component together at a time. We can just include one component. So towards the my the research is like in Malaysia, I try to make it like not the transfer to 4.0, the towards the 4.0. That means we cannot do another, because we don't have this fund. Government have also trying to help these small and medium industries to the convert their or transfer their factory to IR 4.0, but that is not sufficient. We don't have this the amount of financial strength. But what we can actually do is we can shift or transform slowly towards the what we have, or what the thing we can implement just now, and what the thing we can the costly thing we can actually implement gradually. That will be the solution towards the automation. you cannot just the one day my old factory I just remove all the machine and then I just commission all the install all the new automation system. That will be not the wise decision for country like Malaysia, Indonesia. Yes.
Okay, thank you, Prof. Mozassar. Yeah. Okay, I think it's enough, yeah, Mas Rafiq.
Yeah, I think it's enough. I'm happy with the answer from Mr. Farid and Mr. Thank you.
Thank you very much, Mas Rafiq, for your participation. Okay, is there any question for other participants? Please raise your hand. Is there any of you who would like to ask the presenter today? Rizka. Rizky.
Rahmat Saputra.
Okay, Rizky Rahmat. Rizky Rahmat Saputra. Okay, would you please turn on the camera and unmute your microphone?
Okay, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Bismillahirrahmanirrahim. Thank you for the time, ma'am. I apologize if in advance if my English is not good. I want to ask, what is the bad impact of smart manufacture on workers, and what is the solution for that?
Is that all?
What is the bad impact of smart manufacture on workers, and what the solution?
Okay, thank you, Mas Rizky Rahmat Saputra. Okay, Prof. Mozassar, would you like to answer the question first? Then I would like also to hear from Dr. Farid after Prof. Mozassar.
Okay,
Please welcome.
Every we cannot say everything is good for the health, because some they says that this smartphone is not good for health. You have the hearing problem, you have some radiation problem, so better to not use this the smartphone too much like this. So every the system, we have some good and some bad. We have some advantages and disadvantages also. Yeah, in terms of the already the Mr. Rafiq raised this question. There may be unemployment is there a problem for the smart manufacturing. That unless in terms of this, I'm not sure whether your point is this. That may and if your point is like the effect of this, I think that is the good for the the not the bad. It is actually the good for the worker, because 3D work now the in Malaysia or in many countries, the dangerous, difficult, dirty work is done by the people from the other lower income country. Like in Malaysia, this 3D work is doing by Bangladesh people, the Nepal, Bangladesh, and then the Myanmar people. But if this thing changed to the smart manufacturing, then this is good for them. No need to do this difficult, dangerous, and the dirty job by human. They will be healthy, because all these people, they are working in this unhealthy condition, in the dirty work. They become sick after a few years. So that will be, I think, the good. The smart manufacturing, in terms of the some of the points, maybe unemployment, because we need less people to do the work. But in terms of the health and safety, it is good for the worker. That's all from me.
Okay, thank you, Prof. Mozassar. How about you, Dr. Farid? What is your opinion?
Okay, Rizky, thank you for the question. So I just would like to comment. Basically, when you said about the bad impact, okay, so I think the answer have been questioned by Mas Rafiq just now, right? Because yes, of course, for example, there is impact on the employees. If we go for automation, of course, it's definitely it will make it less for humans. And I also agree with what Dr. Mozassar said. It depends on the type of industries. There are also industries that requires the dirty, dangerous jobs and so on, like cleaning and working in the hazard environment and so on. The other impact is let's say if your work if let's say the employment rate have been increased, the unemployment rate have been increased because of the automation. So basically that's why what my suggestion is the government can create policy, because for example just now what happened to Malaysia when we have attacked by COVID-19 pandemic. So we see that there is a lot of unemployment. The unemployment rate increasing drastically. And then what happened? But not manufacturing still survive. This is the truth. This is the fact. But manufacturing still survive compared to other jobs. But what kind of manufacturing still survive, and what kind of services or other industries declining. So what I give example, the emerging, the developing industries or manufacturing sectors because of the COVID is health and care, for example, because I believe Malaysia and Indonesia, we are producer for rubber, right? So the requirement for the latex hand gloves, and then also we have a face mask, that production increased drastically. So that's why sometimes when we have been impacted by certain difficulties, there is another solution for it. Basically, what we call we have hikmah behind it, right? So there's a hikmah behind it. So I believe that, but what we are people, we all humankind, what we can do is basically we sit down together, stick together, and we try to find a solution for that. Inshallah, I believe there will be a solution. Start with at the higher level. Just I said my answer to Mr. Mas Rafiq just now. We start with the higher level. At the same time, at the lower level, like the community level, also sit down and think together how we can solve the problem. For the government level, they can set the policies, which they can identify which industry are increasing because of the COVID and which industry are become decreasing because of the COVID. For example, in aeronautics, for example, air transportation, this one is collapsed very drastically. But in manufacturing, still survive, and some of the manufacturing sectors increasing their production numbers. One major company in Malaysia, Top Glove, initially they produce a rubber-based product for healthcare, for PPE, but now they also produce a face mask, which is basically not their main business before this main product. So that's my side. There is a still what I can say is a negative impact because of the smart manufacturing, but we can do something. From my referring to my answer for Mas Rafiq, we also can develop a support system. One more thing, I read one of the professors in Japan, what they said. Although Japan, we are well known for the robots countries, right? They develop and apply a lot of robots. They said also, although we implement fully automated, but don't forget we still need human touch. Okay, so we need to identify what are the human touch. It's including design, maintaining, services. Because robot, of course, robot now they can in Japan they have a robot to treat old peoples, right? But that's why we still need a human touch for it, because we are.
Okay, thank you very much, Dr. Farid and Prof. Mozassar. Yeah, so it's always like a coin. Yeah, it always both sides. Yeah, bad impact and the positive side from this smart manufacturing. Okay, Dr. Farid and Prof. Mozassar, I would like to ask you something. Actually, maybe you'd like to share about your research experience in smart manufacturing. Maybe you have some experience in smart manufacturing and you would like to share with us.
Actually, the research here is, if you see, because my this is the new field. I already send the proposal to do some survey and try to implement this smart manufacturing or the IR 2.0 to the furniture manufacturing, the industry in Malaysia, because this, the already I think someone, in the furniture, if you look at the furniture shop or in the furniture warehouse, because its size is like a bed, a sofa, a dining table, it's take a lot of the space in your warehouse, in the showroom, in everywhere. So this is a lot of investment. So we can actually reduce this by using some is called this the simulation software or this online platform to reduce the size of this or maybe we can just eliminate the workshop, no need the workshop. People will look to the virtual showroom. The showroom will be the virtual. The people will look the virtual, they will order their furniture, or they can actually design their own furniture and they can order it to the company, and company can make it and then send directly to the customer. So that's I am trying to do some another thing to do, like in terms of this smart manufacturing. My other research is the human robot cooperation, that is the different, but in terms of the smart manufacturing, so that is my thing, to just eliminate this we call this a big space or this the warehouse, because that we cannot make all the machine at a time, this furniture industry, or we cannot replace all the human worker at another time. But what we can actually replace this the place, that will be reduce a lot of the cost of the I think the furniture.
Okay, thank you, Prof. Yeah. How about you, Dr. Farid? Do you have any experience in smart manufacturing research? Yeah, we'd like to hear from you.
Okay, so back to during my masters, after I joined ITSM, and then I pursue my studies in masters in mechanical engineering. It's not totally in manufacturing, but in mechanical. So my project is involved in a project, in a bigger project with a grant, with a national grant. At that time, we developed we call it as a cyber manufacturing. Cyber manufacturing system. At that time, IR 4.0 we haven't heard about it yet, because for me, it's just a new terminology, new name, but it just changed by where the countries or where the parties who create that kind of terminologies. Okay, so in my experience with during my master, so I'm a part of the research team doing that project. So what kind of project is basically is a aquaculture feeding system. Actually, it's not only feeding. My part is for the automated feeding system, where we share using telemetry to share the information. But in that project, we also integrate it with water quality system, and then we also integrate with business. There are a few agencies, for example, Lembaga Kemajuan Ikan Malaysia. So there's one of the agencies, and we also involve with other universities. And then nowadays we also focus on developing smart fabric, smart textile, because we also have one grant, Erasmus grant, is international. So this one finally it has a direction to the smart manufacturing, but we start with the smart product first. We start, because ITSM in our faculty for mechanical department, our manufacturing, one of the main research is developing textile engineering technologies. So textile is a big thing. So in my parts, because I'm have a automation background and mechatronics background, so that's why we developing the smart fabric. And so far the edit initial stage, because when we go there, because there's a potential to be increase the demand for the smart textile. And then we also have now we have also have collaboration with industries developing bamboo production factory, which heading towards the smart manufacturing. From the farm, bamboo farm, we also have bamboo farm here in our campus in Pago. And then at the same time, we have a lot of staff teams in my parts developing machine. That's why my interest in the automated machine system. And perhaps one day we are heading to a smart production line. We try to have our own what we call lab scale production line first, then we can implement it in industry.
Okay, it's very interesting, Dr. Farid and Prof. Mubazasar. Maybe we can make the collaboration research in the future, yeah, between UHCM and Unisula, yeah, especially with Industrial Engineering Department.
Yeah, inshallah. We would like to.
Oh, the COVID is already gone, then we can visit UHCM, and UHCM can visit Unisula in Semarang. Yeah, inshallah.
Inshallah. Amin.
Okay. Okay, is there any anyone who want to ask the question again? Okay, I think it's enough. Yeah, we finally come to the end of our discussion today. Before I close, I would like to, not the conclusion actually, Dr. Farid and Prof. Mubazasar is already explained clearly about the topic today, about smart manufacturing and about Industry 4.0. But the things that we can get from the discussion today is new emerging of the technology can stimulate the evolution and adoption of smart manufacturing, where it depends on the nature of production business and actually about the country regulation. Yeah, I like your statement, Dr. Farid. Yeah, it depends on the government. Yeah, the country regulation, how to keep the people still employed. Yeah. Okay, and before we end this webinar, I would like to extend our gratitude to the speakers for the very informative and very interesting presentation today about smart manufacturing and Industrial 4.0, and also to all the participants for the participation in our webinar today. Thank you very much. Hopefully the talks will be beneficial for everybody. As the moderator, I ask for you apologize if there were some mistakes that I might made during this webinar. I do hope that we can meet again in another agenda soon. Yeah. And finally, please give the big applause for the speakers and for you all. Yeah. Once again, thank you very much, everyone, and have a nice weekend. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
And I will return this agenda to the Master of Ceremony. Please welcome Mrs. Indah.
Okay, thank you very much, Ms. Wiwi, for guiding this session wonderfully. And special thanks to our great speakers today, Dr. Muhammad Farid bin Sari and Associate Professor Dr. Muhammad Mubazasar Rahman from University Tun Hussein on Malaysia. Ladies and gentlemen, please give a big round of applause to our speakers and moderator. Thank you. What an interesting discussion today. So hopefully we can meet again and have another interesting discussion in the next time. And now, ladies and gentlemen, we would like to present token of appreciation to Dr. Muhammad Farid bin Sari and Associate Professor Dr. Muhammad Mubazasar Rahman for sharing this expertise to us today. Please, from multimedia team, you may share the appreciation. Okay, the first certificate of appreciation will be given to Dr. Muhammad Farid bin Shari. Thank you, Doctor, for sharing the knowledge today. And the second one, is for Associate Professor Dr. Muhammad Muzdasir Rahman. Thank you very much. Okay. Ladies and gentlemen, the whole agenda of industrial engineering webinar today is coming to the end. So once again, I will remind to all the participants to fill up the attendance form that already given in the chat box. And then for your information, we will still have another webinar series for the next 2 weeks. And then for the next week, the webinar will be hosted by Informatic Engineering Department. So make sure you join and then register for the event. Now, once again, we would like to express our great appreciation for all speakers, main organizer, committee, and participants. So hopefully we can meet again in another time, and thank you very much for your attention. I close this webinar series. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Wabarakatuh. Thank you very much, Dr. Farid.
Doctor, if we want to contact you, so can we propose write email to Dr. Nuzulia for any potential collaboration next time?
Of course, you can contact the Bu Nuzulia as the head of Department of Industrial Engineering.
Okay. Thank you.
Yeah, we hope our agenda will be continued, Doctor.
Inshallah. Okay.
Thank you, everyone.
Thank you very much, everyone. See you.
Okay. Stay safe. Assalamualaikum.
Wiwi, terima kasih. Mbak Indah, terima kasih.
Sama-sama, terima kasih semuanya.
Panitia dan juga
Bulia, don't forget to contact speakernya untuk minta materinya.
Ya, terima kasih semuanya Bu Wiwi, good job Bu Wiwi. Alhamdulillah.
Terima kasih Bu Ibu, Bapak-bapak semuanya.
Saya maaf nggak bisa download ini ya tadi backdropnya. Ada something trouble di sini. Ya, alhamdulillah lancar ya. Bu Lia, terima kasih.
Ya, sama-sama.
Insya Allah menjadi doa Dr. Wiwi and Dr. Nuzulia, insya Allah.
Profesor Novi juga.
Profesor Novi, yes.
Iya, kita aminkan.
Live on YouTube loh, masih live on YouTube.
Oh iya, nggak apa-apa, alhamdulillah. Kan menjadi doa diaminkan semuanya, insya Allah.
Amin ya Allah.
Iya, terima kasih. Ada yang mau tanya link absensi, sepertinya dengan itu ya di website seminar ya. Ada yang
presensinya ini sama dengan pada saat pendaftaran yang kemarin ya.
Iya, di seminar itu ya.
Di leafletnya. Sepertinya tidak di-share ulang ya ternyata.
Iya. Lewat website seminar FTI itu ya Mbak Indah ya?
Betul Bu, lewat website.
Iya.
Silahkan mengisi di situ ya.
Iya. Ini mungkin bagi yang masih standby.
Izin live ya Bapak Ibu semuanya.
Ya, terima kasih Bu Wiwi.
Sama-sama. Terima
Saya
kasih
izin dulu, Bapak
semuanya.
Ibu. Oke, so ya.
Mas multimedia
Live-nya
mungkin bisa
live
di
ya.
end meeting.
Oke.
Ya.